Hello, my name is Kyle Smith. I'm a senior at Millersville University studying occupational safety and environmental health, and today I'm going to be talking about the basics for completing a fault tree analysis. So the scope of the presentation that I'm about to show you is, first we're going to go over some common terms associated with the presentation, just so you guys are on the same page and can understand what I'm talking about. Then we're going to get into what exactly is a fault tree analysis, the procedures on how to complete it. Then I'm going to show you a basic structure with some symbols associated with it. Then I'm going to show you some pretty easy examples. There's 2 of them in here. And then we're going to get into some advantages and disadvantages. And then we're going to wrap it up. So some commonly used terms I would like to talk about that I'll be talking about throughout is, the first one is system. So what exactly is a system? A system is a set of connected parts to complete a complex idea or device to make it work. For example, it can be like an engine, your lights in your household, even your stove, or it can be just a general problem such as a fire if one were to occur. We're going to be talking about system failures throughout this presentation. So a system failure is when an error occurs either by human or software/hardware complications. So pretty much, if the system just doesn't work out as designed. And then risk management, I wanted to highlight this term because, risk management is identification, assessment, and prioritization of risk. So pretty much we're just identifying and assessing risk to try to reduce anything from happening that would cause a fault. So what exactly is a fault tree analysis, and why is it important to system failures? Well, fault tree analysis is a deductive approach to failures. So you start with a top undesirable event, and then you work your way down the tree and the schematic. It's used to quantify system failure probability. Now you can assess which failure is going to happen more often than not. We're not really going to get into that throughout this presentation, but it's just something to highlight when you start getting more into advanced details with fault tree analysis. Fault tree analysis is used to evaluate potential upgrades to a system. So you can identify potential risk and hazards before it even happens. And if you identify something that could go wrong, you can eliminate it before it actually happens to make your system more safe and less prone to faults. So the general procedure to complete a fault tree analysis, I broke it down into 5 pretty simple steps. First, you want to define the system. You want to define the hazard. 2, you want to identify the causes for the top level event. 3, you want to identify the next level events if there are any. It all depends on the system. There could be many second level and basic events, or it can be just a very general basic system. So it doesn't have to be complex if you don't want it to be. Then you want to identify some root causes associated with it, and then at the end you want to analyze it and see what you can do to reduce the system from failing. So this is a basic structure of what a fault tree analysis looks like. As you can see, the top of the structure is a main event, and if you can zoom in, you could also pause the video to actually take a better look at this. But on the top, the basic structure of a fault tree analysis is broken down into a couple different events. So, of course, on the top is the main event. Then it goes down into intermediate events that follow the main event, and then basic events underneath the intermediate events. One of the most important things to note are the logic gates. As you can see, there's an AND gate, another AND gate, and an OR gate. They both have different symbols associated with it, so you can determine it when the schematic gets a little cluttered. But one thing to note is with an AND gate, all the events below it must fail at once for the main event to fail. Or in this instant, these events need to fail at the same time for this event to fail. For an OR gate, if one event fails, then the whole event above it fails. So if one of these event fails, that means this is gonna fail no matter what. With the AND gate, both of these need to fail at the same exact time for the main event to fail. So in our first example that we have here, it's a pretty general example, but it gives you a really good gist of, the gates and how they associate with one another. So our first example is a fire breaks out. So it's followed by an AND gate, which again means all events below must fail at once for a fire to break out. So a leakage of flammable liquid is on one side, and an ignition source is near fluid. If there's just a leakage of flammable fluid, a fire won't break out. There has to be an ignition source near fluid. But for this to happen, there's an OR gate, which means one of these only needs to happen for there to be an ignition source. So if a spark exists or an employee smoking, that has potential to ignite the flammable fluid, thus causing a fire to break out. Example 2 is a pretty general example too. It's your car will not start. If you can zoom in a little bit more for that so they can see it. Again, it's just followed by an OR gate, meaning that if one event fails, it all fails. So if this event fails, the car will not start, and if this event fails, it will not start. And it's a pretty general example as well. Example 3 is just how complicated these fault tree analysis can get. So you can get into as much detail as you want. But for everyday use, you can make a pretty simple one. So some advantages that we have here are you can identify failures from the top down. You can also highlight the important elements of the system related to the system failure. You can create a graphical aid for system analysis and management, and you can focus on one fault at a time. Disadvantages, they may take very long to complete, not in all cases though. Also, sometimes you might have to be an expert on maybe one of the systems, which also can take a while to complete. So it might require specific expertise to identify every single event. But if you're working with a team, you can have a collective approach and handle that fault tree analysis together. So this presentation, first we talked about some key definitions. Then we talked about what exactly is a fault tree analysis, which is a deductive approach from a top-down system to figure out a problem. Then we went over the procedures, the basic structures, a couple basic examples with a complex example as well. And then we talked about the advantages and disadvantages, and now we're wrapping it up. So thank you very much. I hope you learned something new with this fault tree analysis. My name is Kyle Smith, and thank you very much.